Hello, here is your Unit 5 study guide explained. Here is a story. Noah was at home. He got on his bike and rode to his friend's house, and he stayed there for a while. Then he rode home again. Then he rode to the park. And then he rode home again. Take a look at the situations, the graphs here. You're going to circle the graph that represents this situation. Notice that on the x-axis for all three graphs is time, and on the y-axis is his distance from home. So I can eliminate right away graph B because this is saying that he's not home at the beginning. He's far from home. Now looking at graph A, he begins at home, leaves his house, and then returns to home, leaves his house, and then returns to home again. And I think that's what we read. He's at home, stays there, goes on his bike, and goes to his friend's house. He goes home again, rides to the park, and then returns home again. So I think it's going to be graph A. When I look over at graph C, he's at home, but you can see he doesn't return to home in the end. So let's go ahead and select choice A. Identify if the table is a function and why. It doesn't have to be a linear function, just a function. Remember, to be a function, every input has exactly one output. Okay, so looking at table A, I'm focusing on the inputs here. I can see all of these inputs are different numbers, so that's a good sign that this is a function. Every input has exactly one output. There's no repeaters there. So I'd also like to show you on a graph how this would pass the vertical line test. So I'm going to plot each point, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, I put them all in a graph. Now, if I do the vertical line test, you can see it passes. Okay, so you can see as I pull a vertical line across, at -2, only 1 point touches. At -1, only 1 point touches. At 0, only 1 point touches, and so on. So it passes the vertical line test. So table A is a function. Let's check table B. Okay, so we focus on the inputs. Every input has exactly one output. So let's see, I have 4, that's fine. Oh, look at, I have +1 here twice. So this is not going to be a function. Let me show you how it doesn't pass the test when you graph the points. So over 4 down 2, over 1 down 1, 0, 0, 1, 1, and 4, +2. Ooh, twice it doesn't pass the test. Okay, so watch when I pull the line across. It's fine here, but see how right here 2 points are on the same line? And also right here 2 points are on the same line. That means the input of 1 has 2 different outputs. See how it has 2 different outputs? And the input of 4 has 2 different outputs. So this is not a function for table B. Okay, and let's check out table C. It looks like the inputs are all different values, so that's a good sign. Let's graph it and see what happens. 1, 0 is right here. 2, 0, and 3, 0. Oh, this is going to pass the vertical line test. Watch. When I pull the line across, every input has exactly one output. Okay, so that passes the vertical line test. So this is a function. Okay, so the outputs can repeat as long as the inputs are all different, then it is a function. Okay, now we're going to look and see which of the following are a function. These are called mapping diagrams. But you're looking for the same thing. You're looking to see that all of the inputs have exactly one output. And see how 10 pairs with 15, 20 goes with 45, 30 goes with 25, and 40 goes with 35. So we have all different inputs. So table A is a function, or mapping diagram A, that is a function. The second one here, now notice that 3 pairs with 4 different things. This is not a function because the input of 3 has 4 different outputs. That is not a function. Looking at your next example, I see right away that 2 pairs with 20, but 2 also pairs with 40. So that is not a function. Every input can only have exactly one output. And then our last mapping diagram, let's see, every input has exactly one output. So that is a function. You know, in all these, you could put on a graph and try that vertical line test, but just know if the input repeats, it's not a function. Okay, same idea here. Is this a function? Does every input have exactly one output? Let's see, 15 pairs with 6, 16 pairs with 14, and 14 pairs with 1. So all of these are different inputs. They all have exactly one output, so you would circle yes. This is a function. Okay, is this a function? So looking at this graph, every input has exactly one output. I'm kind of eyeing up right here. This would be 1, 2, 3, 4, 5. The input of 5 would have 2 different outputs. It also does not pass the vertical line test. When I pull the line across, this is fine because only one point hits the line, but right here, you see how 2 points are hitting the line here and here. So this is not a function, so we would say no. Is this table linear or nonlinear? So linear means it's going to make a straight line if we were to graph it, and nonlinear would be some sort of curve. So I did pull up a graph here, even though you don't have a graph on yours. I'll show you how to do it with a graph and without. So with a graph, I would plot -1 and +8, which would be right here, and 0, 11, and 1, 14. And then I would see if those make a straight line. So we'd see if they have the same rate or same slope the entire time. And it looks like that does create a straight line, which would be linear. So now let's go to the table, which is what you have, and determine if in fact it is a straight line. To do that, we would do the rate of change throughout the table. So I'm saying, looking from here to here, from an 8 to an 11, that is an increase of 3. And from a -1 to a 0 is an increase of 1. I would have to make sure that that rate of change is the same throughout the table. So I'm going to look at the next set. From an 11 to a 14, that is also an increase of 3. And from a 1 to a 0, that is also an increase of 1. So it is consistent. The rate of change is consistent. That is the slope. So I'm going to say yes, for sure, this would make a straight line. The rate of change, or the slope, is 3 over 1 each time. So that is consistent. And if I connected these, it would make a straight line. For question 7, we're going to choose graphs that represent linear functions. So that's 2 parts. It has to be linear, which is a straight line, but it also has to be a function. For every input, there is exactly one output. So I can tell, looking at these 3, that letter C is already eliminated because that is not a straight line. The other 3 all have straight lines, but are they functions? I'm going to do the vertical line test to show you that A is a function. Every input has exactly one output. As I move the line across, you can see that the X values have only one Y value. So letter A is a function. As I continue to move the line across for B, Letter B, even though it has a zero slope, is still a function. Every input has exactly one output. For example, -1 pairs with 3, -2 pairs with 3, -3 pairs with 3, and so on, going across the positive values. So when I move this line across, every input has exactly one output. So letter B is also a function. So I'm going to say A is a function. I'm going to choose that one and choose B. Okay, now let's look at graph D. Let's see what happens here. When I do the vertical line test, the whole line shows up on the line that I'm pulling across. This does not pass the vertical line test. Also, if I pull out the points that are on this line, you can see that 2, the input of 2, has the output of 0, the output of 1, the output of 2, the output of -1, -2, and -3. So this does not pass the vertical line test. You can see that the input of 2 has all of those outputs. So graph D is not a function. Okay, so just A and B. Question 8, complete the t-table and write the function rule or the equation. So let's take a look at the t-table or t-chart here and see what's going on here. I definitely see a pattern when I go from the input to the output. I can see that going from 3 to 24 and 4 to 38, that looks like you would multiply those by 8. Because 3 times 8 is 24, and 4 times 8 is 32. So I think that's going to be the rule because that works for both of those inputs and outputs. So if I do 1 times 8, I'm going to get 8. So I'm going to fill 8 right in here. And then 2 times 8 equals 16. Okay, so let's make sure that all works. So that would mean our equation would be to get the letter G, I would have to do the letter C, because we're using the variables C and G here. I would have to do 8 times C. And I can actually simplify that a little more. I could say G equals 8C. I can make that multiplication sign invisible. Okay, so that is our rule, our equation, and I used the G, the output, and the input. I used the letters that were in there. We're used to using X and Y, but in this case, the variables are C and G.